Okay, we are live on Facebook, and I have started recording on this computer. So welcome to the 5th session of Vedic Math with Technology Interludes for ages 8 and up. So in the last few sessions, we covered one of the sutras, Ekadikena Purvena, which is a sutra in the Vedic Math. And then we covered a verse from the Rudram. It's from the Krishna Yajurveda. And we saw how how we can pray for everything in this universe using numbers. Ekachame, Tisraschame. So this basically is a prayer to Lord Shiva to bestow upon us everything that is good in the universe. And we do that just by using numbers. So we saw the significance of the numbers in the verse, in the Vedic verse, Vedic hymn. So there are multiples of 4 and there are odds, yeah. Now today we are going to cover the significance of 108. So 108, you know, is a very important number for in many cultures. The rose bead, the bead of rosemary bead, typically has 108 Rudra. No, the beads. They are actually seeds. The beads are actually seeds.
The ones that people put like a necklace on and then like
count. Yeah. Those plants are widely found in Hawaii. So we can search. But yeah, typically so if you search for Rudrakshamala, so Rudrakshamala, number of beads, 108. So there are like 108 beads. So you repeat, the idea is that we repeat a mantra 108 times, mantra or whatever that we are meditating upon for 108 times. So 108 is a very powerful number, and it has been established. It is a powerful number for a number of reasons. In terms of number theory itself, it's a product of the powers of 1, 2, and 3 themselves. So 1 square times 2 squares times 3 square is 108. The first 3 numbers squared and multiplied together will give you 108. It is called Harshad number. Harshad means happy. Harsha means happy. The definition of Harshad numbers is an integer divisible by the sum of its digits. So 108, the sum of the digits is 1 plus 0 plus 8 is equal to 9. And 108 is divisible by 9, right?
Times 12.
Yeah, 9 times 12 is 108. So it is a Harshad number. So it's a happy number. And there is another significance, another interpretation of 108. So 1 is like God or higher truth, right?
Everything.
Remember, even in the last class, we talked about Prakriti and Purusha, right?
Yeah.
Purusha is like 1 and Prakriti is like 0, right? So, so in that sense too, 1 can be thought of as God. Zero can be thought of as emptiness or completeness, depending on how you see it. So zero is a circle. It's complete in itself.
But it's also empty.
It's also empty because it doesn't have any value. Yeah, it is empty inside the circle. And then it doesn't have any value as such. So you can either treat it as emptiness or completeness. And 8 is a symbol for infinity, right? Vertical symbol. If you
Flip it
flip it horizontally 90 degrees, you get infinity. So 108 has that kind of a significance also.
And why did they choose the order 108?
So God is complete, or you can think of it as God is from emptiness to infinity. You can think of it that way, right? 1 is God, 0 is empty, and 8 is infinity. So you can think of 108 conveying that God covers everything from emptiness to infinity or eternity. So you can think of it that way. And 108 appears a lot in the Rig Veda. So Rig, if you remember, means praise. So Veda is about enormous concepts, huge concepts that deserve praise. And what is the first concept that comes to your mind, which is enormous, all-pervading?
The sun or everything, the universe.
Yeah, even beyond that is the God, right? God is all-pervasive. So the Vedas are about God, the cosmos, the astronomy, the universe, everything that is gigantic. The Rig Veda praises, right? Rig Veda is about enormous concepts. So some people have interpreted Rig Veda as a huge astronomical code of the cosmos, and 108, and it uses 108 in a number of places. So in the construction of temples for doing homas, yajnas, 108 number has been suggested. So, and then 108 is built into the universe in a number of ways. So the distance between Earth and Sun is 108 times the diameter of the Sun. So this is there's also in Hanuman Chalisa, there is a doha, or one of the verses in Hanuman Chalisa goes, Yuga Sahasra Yojana Parabhanu Lilyo Tai Madhura Falajan. Yuga Sahasra means, Yuga means
1,000 yugas.
Yuga means actually 12,000 years. Sahasra means 1,000. Yojana is approximately 9 miles or 8 miles. So Yuga Sahasra Yojana Parabhanu. Bhanu means Surya, right? Bhanu is the god, sun god. So Yuga is 12,000 years, Sahasra is 1,000, and Yojana is an ancient measure, and it's approximately 8 or 9 miles. So when somebody says Yuga Sahasra Yojana, it is 12,000 multiplied by 1,000 multiplied by 8 or 9. So which is, if you take Yojana to be 8 miles, it will be 96 million miles. So 96 million miles is the distance to Sun. Even today, if you look at this, right? So distance to Sun, what is the distance to Sun? $94 million miles. So which is roughly that, Yojana Parabhanu. slightly more than that, but it's roughly that. I mean, compared to millions of miles, we are pretty close. So in Hanuman Chalisa, what Tulsidas, the author of Hanuman Chalisa, says is that Yuga Sahasra Yojana Parabhanu Lilyo Tahi Madhuro Falajanu. So Hanuman thought that the sun, which is Yuga Sahasra Yojana away from us, as an apple. Phala, fruit. Phala is fruit. Yojana Parabhavan. Lilyo Tahi Madhura Falajanu. Hanuman thought that it's a Madhura Phala. Madhura means sweet fruit. So see how accurately, and when was this discovered? Discovered 1653. And when was Tulsidas born? 1532.
Wow.
See, in 1532, Tulsidas wrote Hanuman Chalis. I mean, around 1532 he was born, but he must have written Hanuman Chalisa maybe when he was like 30 years or 40 years or whatever. So he certainly died before 1623, which is before the time the astronomer Huygens calculated the distance from Earth to the Sun.
Wow.
See, our culture is so rich. Unfortunately, it did not get the credit that is due to it. Right? So that time itself, we calculated the distance to the sun and said that the sun, which is at this distance, appeared to be a Madhura Phala, means a sweet fruit to Hanuman, and he jumped to eat it. That's what Hanuman Chalisa says. So, so there's a lot in our culture that is very scientific. So, so Yuga is 12,000 years, right? And there are 4 yugas. We talked about it previously also, right? There's Satya Yuga, Treta Yuga, Dwapara Yuga, and Kali Yuga. So the longest yuga is the Satya Yuga.
Very first?
Yeah, the very first. And it has 17,028,000 years, which is a multiple of 108. Let us look at this. Or I will, how do I do this? Okay, I can do calculator here also, right? So if you look at, so what were we trying to do? 17,028,000 divided by 108. 16,000. See, it is divisible by 108. And how many years in Treta Yuga? Satya Yuga, we know is that much. Treta Yuga, number of years. 12,096,000 years. Sorry, what am I doing? 1,296,000 years. So is that also divisible by 108? Is 1,296, 3 zeros, divisible by 108. Oh,
Maybe just divide it.
Maybe just do.
Yeah, I think I should just do this. 1,296,123 divided by 108. It is again 12,000 years. Yuga. So That is Treta Yuga. Dwapara Yuga also, number of years in Dwapara Yuga. 8,064,000 years.
8.
So 864, 1, 2, 3 divided by 108. 8,000.
It reduces by 4.
Yeah. So you get the idea, right? And okay, let us look at Kali Yuga. This was Dwapara Yuga, right? Yeah, Kali Yuga. Number of years in Kali Yuga. 4,032,000. So let us do this. 432, 1, 2, 3 divided by 108. And that is 4,000 years. So as you can see, 108 is the common factor for all these yugas, right? And Kali Yuga is 4,000 times 108. Dwapara Yuga is 8,000 times 108. Treta Yuga is 12,000. And Satya Yuga is 16,000. See, and the common thing is 108. So 108 in that sense also is very important. It tells the time. It is a factor in the time. And we all know that the set of these 4 yugas keep repeating, right? We talked about it in the past,
Yeah,
one of the previous classes.
20th.
Yeah.
Sometime.
And one cycle of these 4 yugas together is called a Mahayuga. And Mahayuga is,
The Great Yuga.
it is, if you count, it is, if you count all, the number of years in Satya Yuga, Treta Yuga, Dwapara Yuga, Kali Yuga, it will be 4.32 million years. Right? So, which is also a multiple of 108. I mean, all the 4 yugas are anyway multiples of 108. So, the Mahayuga is also a multiple of 108. So, what else about? So, 108 is really, and the distance between Earth and Moon is also 108 times the diameter of the Moon. See, even astronomy is full of 108s, right? The distances in the universe are also measured in units of 108. And the diameter of the sun is 108 times the diameter of the Earth. The distance between Earth and sun is 108 times the diameter, and the diameter of the sun itself is 108 times the diameter of the Earth.
Wow.
And you all know that in astrology, when you look at your astrology every week, right? There are 12 houses and 9 planets.
Capricorn, Taurus.
Right.
Scorpio.
The 12 houses are Leo, Capricorn, Taurus, Aries, and all that stuff. And there are 9 planets. These 9 planets can sit in any of the houses.
Navagraha.
Yeah. Yeah, Navagrahas. That's right. So if you look, I think there is an app. There's a very good app. You can see the constellations. Remember, there was an app we downloaded on Android.
You move it around the sky, then it'll.
Yeah, you look at the sky, you point it to the sky, it will show you the exact positions of the planets and the constellations and all that. I don't think, okay, let us see. Leo constellation. Images. See, it looks like a lion. The stars are aligned like a lion. So the planets, the 9 planets can be in any of the 12 houses. So and I don't want to go into astronomy, but so that's the idea, right? You all know astrology.
Yeah.
So there are 12 houses and 9 planets. So 9 times 12 is 108. See, astrology, the universe is all about 108. It's a magical number. And the angle formed by two adjacent sides of a pentagon is 108.
Wow.
Right? What is the angle formed by the two adjacent sides of an equilateral triangle? The sum of the angles of a triangle is
180.
180. So equilateral, all the angles are equal.
Right.
So it will be
60.
Yeah, 60. 180 divided by 60. Similarly, in pentagon, it is 108. It is because it's slightly, there are more edges, right?
Yeah, 5.
So 108. And and in astrology, the metal silver is said to represent the moon, and the atomic weight of silver is 108. See, it's all connected. Everything is connected to 108. You can look at more in this page, actually. So when you look at Wiki, it tells you in mathematics, 108 is an abundant number, semi-perfect number, Tetranashi number,
What is
Fibonacci number form. So Fibonacci numbers, they form this kind of recursive definition. So 0, 1, what will be the next number? Can you tell me?
2.
2, no, why? So the first two numbers are 0 and 1. And to get the next number, you have to add the previous two numbers.
Oh,
Fn is equal to Fn minus 1 plus Fn minus 2. So 0, 1, and next what will come?
1.
1. And next, what is it going to come?
2.
2. Next?
3.
Next?
5.
Are you sure? Yeah,
Yeah,
5. And next?
8.
Yeah, 8. So that is the definition of Fibonacci numbers. Tetranashi numbers is actually when you learn programming, that is one of the first programs that you write, Fibonacci numbers.
Is there a programming a coding thingy called Fibonacci sequence or something?
Yeah, it's the same thing as Fibonacci sequence. And Tetranashi sequence as Tetranashi numbers start with 4 predetermined terms. Instead of 2, there are 4. And then each term afterwards being the sum of the preceding 4 terms, not 2. If it is 2, it is Fibonacci. If it is 4, it is Tetranashi.
Oh, because tetra means 4,
4,
isn't it?
yeah. So, so 108 is called the Tetranashi number. And it's hyperfactorial. So there's so many in Hinduism, see, Shivaganas, Mukhya Shivaganas are 108 in numbers. Use the malas of 108 beads. And even in Vaishnavism, 108 followers known as gopis for Lord Krishna, right? So Jainism, Buddhism, all this, I mean, these are all derived from, these are all offshoots of, Buddha did not even form a religion, but people call it Buddhism. Buddha was a Hindu, I mean, he practiced Hinduism. But because his followers knew only Buddha, they thought that whatever he was teaching is Buddhism, because they didn't know about Hinduism, right? So a lot of stuff in Buddhism is actually from Hinduism anyway. In martial arts also 108 is a famous number. In literature, the number of suitors for all this
Oh, I see.
literature.
That's Greek mythology.
Yes. So 108 plays a very big role in many areas in technology. 802. This is the Ethernet. No. This is the 802.11g is the wireless, right? Is it specific in the yeah, it's a wireless Wi-Fi band. This is one of the first protocols, G. Later on, there was N and then AC and all that stuff. So your Wi-Fi protocol also uses 108. So card games, there's so much about 108. It's a really powerful number, and that power was described in the Vedas. It was described in the Vedas because the whole idea of this yugas is from the Vedas, right? So 108 comes from the Vedas. So that is an important thing. And there's a lot more stuff on so there's a lot more. There are many websites describing the significance of 108. Right? If you look at this website, so dharmic practice, why 108 is in the yogas, in the Sanskrit language, everywhere 108 is very actively used. So 108 is a significant number, which was highlighted in the Vedas before anything else, before anyone else highlighted it. Right? So we talked a lot about how numbers can be interpreted. The numbers in the Vedas can be interpreted to mean really some very powerful concepts in the world, right? So in the 11th Anuvaka of Rudram, we saw how the multiples of 4 and the odd numbers till 48. They all represented really powerful concepts, all the good things in the universe, right? So 108 is another number from the Vedas, which represents many good things. Now let us go the other way around. Let us interpret some of the things in the Vedas as concepts, as numbers rather. So in the previous few slides or previous classes till now, it was numbers to concepts. Now concepts to numbers. People have interpreted concepts in the Vedas as numbers. So for instance, in the first book of Rig Veda and 50th hymn, the 4th verse of the 50th hymn in the first book of Rig Veda is this. Taranir Vishwadarshato Jyotis Kradasi Surya Vishwama Bhasirochanam. So Taranir Vishwadarshato Jyotis Kradasi Surya Vishwama Bhasirochanam. So what does that mean? Some of the words you can clearly identify, right?
Jyoti
So Jyoti is light. Surya is sun. Vishwa is universe. Darshato means appearance. And what else? Vishwama means universe or eternal. Yeah, you can think of it as eternity. Bhasi means illumine. Bhaskara means somebody who creates illumination.
That's what we call Surya Bhaskara.
Yeah. So Bhasirochanam means Bhasi means illumine. Rochanam means spread, radiate. So it basically means that swift and all beautiful are you, O Surya, maker of the light, illumining all the radiant realm. So everything that is bright and brilliant and radiating is because of the sun, right? So this is from the Rig Veda. Now, one of the so today ministers are politicians, and I don't want to comment much on their abilities, but in the olden days, ministers and kings were highly educated and very well versed. They were pandits themselves. So in the 14th century, Sayana from South India, he was a minister, and he interpreted this verse like this: Tadhacha smarayate Tadhacha smarayate yojananam sahastram deve dve dve. So the with the bar underneath is the dve. So dve dve shate dve cha yojane ekena nimishartha nakramana namostute. So this is the interpretation of this verse from the Vedas by Sayana. So what does this mean? He used Sanskrit to interpret the original verse, right? And some other words are again known to us. So tada means
That.
Yeah, that. Cha means and. Smaryate.
Smara means memory.
Yeah, remember. Yeah, memory, right. Yojananam. We just talked about Yojana. Sasra Yojana Parabhanu.
One.
Yojana is a measure. It's an
9
ancient
miles.
measure, around 8 or 9 miles.
Sahasra is
Yojana
1,000.
and Sahastram means 1,000. Dve, dve.
Two?
Yeah,
Two or
dve is
12?
2. Dve is, 12. 12 or 2, that's right. Dve, dve shate means 2,000.
22?
Yeah, 22, you're right. 2200. Shate means, shata means 100, right?
Oh.
Dve, dve shate means 2200. Dve again means 2. So 2202. Cha yojane. That means 2202 yojanas. Ekena means in one.
One.
In one. Nimishardham. Nimishardha.
1 minute, 1 second, 1 moment.
Nimisha means a moment. In Sanskrit, nimisha measures the blink of an eye.
Same thing in Telugu, right? Okka nimisha.
In Telugu, nimisha is more like a minute, but in actual pure Sanskrit, it measures the time of a wink of the eye. So which is like a fraction of a second, right? So in half of that nimisha, the Surya travels 2202 yojanas.
Wow.
That's what Sayana interpreted this as. Kramamana namostute. Kramamana means travels. Right? Namostute, you all know, means we pray to God, Surya. So he says that in English, it is remembered here that sun, or the light that sun provides, traverses 2202 yojanas in half a nimisha. So 2002 yojanas. So 2002 is, yojana is like around 9 miles, right? So let us do the calculation. 2002 times 9 miles, around 9 miles.
Wait, 2002 or 22,002?
2202. Shata is 100. So 2202 is 2202, right? So which is 19,818 miles, right? And this Surya travels in, or the light travels, it's not Surya, but the light from Surya travels in 19,808 miles in a blink of an eye. And how much is a blink of an eye?
Less than a second.
Duration of a blink of an eye.
Half that, right?
So it says 100 to 150 milliseconds.
So half that would be 50.
No, but that is too much of variation. There is like 50% more. 100 to 150 is a very wide range, and that doesn't help. Okay, let us look at nimisha in seconds.
So less than a
Yeah, 0.2 seconds, 0.2112 seconds. So half of that. So 0.2.
So 0.1-ish?
Yeah, point.
I'm sorry, 0.01.
0.211. 0.211. How much was that?
2.
112. 112 by 2. 1056. So in 0.1056 seconds, Surya travels how many miles did you think?
1,900.
Somewhere here.
198.
Yeah, 19,818 miles. So how many miles would you travel in 1 second?
10 times that.
Roughly, right?
Yeah.
So yeah, this is 0.1. So the inverse would be
Times 10.
around times 10.
So then
So 198,000. Yeah.
198,000.
Yeah, 198,000 miles per second. Okay, let us look at the speed of light. In mph, miles per second.
What would that be in PS?
It will be in miles per second. 186 to 82. Pretty close, right? 190,000 and 186. So see, and Shayana lived in the 14th century.
Wow.
And when was this speed calculated? When was this, according to the world, when was the speed of light? When was the speed of light discovered? 1676. And Shayana lived in 1300 something. So Shayana, using Rigveda, from the Rigveda, he discovered the speed of light how many years back? At least 300 years before what the world thinks when it was discovered. See, that is the power of Vedas. Just by reading the Vedas. See, this sentence does not anywhere tell, rather. So this sentence does not, this verse does not have any numbers in it, right? But just by reading it deeply, Sayana, who was a minister in somebody's court in South India, he interpreted he came up with the distance of the sun, a distance, rather speed of the light, which the sun radiates. See, that is the power of the depth of Vedas, number one. Somebody who reads Vedas will be able to see, he's saying tada. Tada means he is relating this sentence to this. So from this, he's deriving this. That's what he says. So Vedas are both ways. Numbers in Vedas represent very deep concepts, and concepts in Vedas represent very powerful numbers. Right? Rig is all about praising, all about gigantic things. So reading Rig Veda, people were able to interpret the speed of light. 300 years, at least 300 years before it was invented by somebody else, which the Western world thinks that is the time when it was invented. See, that is the power of Vedas and numbers and our learning. So going back to we did not talk about machine learning for quite a while. So let us talk about machine learning, which is all about numbers, right? Okay, first I had to end the show. So it is all about numbers. So we saw how faces can be generated, right? And what is a face to the machine?
Pixels.
Pixels, and each pixel is a number. It could be a grayscale number, or it could be an RGB number, right? So so we saw how machine learning can be used to generate faces, right? And we saw some gates. This is a gate, right? OR gate. This is a fundamental unit in all electronics.
Yes.
Input gate and OR gate, and there's an AND gate. And when you combine both of them, you get an XOR gate. Not both of them, sorry. This XOR gate is a different kind of gate, which can be constructed by combining the two. So XOR, the output is not linearly separable, right? You cannot draw a line because 1 is in the middle and zeros are on either sides of 1 1. Whereas in this case, 1 is on one side, all the 3 zeros are on the other side. In the previous case, 0 on one side, 3 ones on the other side. But in case of XOR, you cannot draw a single line. It has to be like something like a circle or something, right? To separate zeros and ones. So this can be achieved by combining, so it is not linearly separable. We can generate the same functionality of an exclusive OR gate. So that means if you give 0 and 0 as inputs, you get 0. If you give 0 and 1, you get 1. You understand the meaning of exclusive OR, right? So what is an OR gate? When either see OR gate. So what is an AND gate? Okay, let us look at OR gate. What is an OR gate? If both are zeros,
Then it's 0.
Then it's 0. If either one of them is 1 or both of them is 1, then it is a 1, right? It's logical. And AND gate is the other way around.
When both conditions
When both have to be 1, only then it is 1. In all other cases, it is 0. And exclusive OR means it has to be exclusively 1. So if one input is 1, the other input cannot be 1. That is what is meant by exclusive. So you have a toy exclusively for yourself when nobody else can touch it, right? So exclusive OR is when when one input is 1, excludes the other input from being 1. So that means this is out the case when both are 1s, the output will be 0. And it is not linearly separable. But you can generate the same functionality by using linearly separable units. So AND gate, and these two are AND gates. And what is this gate?
Exclusive OR.
No. Exclusive OR has this kind of there is a line like curve like this, right? This is the OR gate. Remember the OR gate? OR gate looks like this. If this line is straight, it is AND gate. If this line is curved, it is OR gate. And if it is curved and there is another line here, it is exclusive OR. Right? So you pass the same A and B inputs, you pass through these gates. These are NOT gates. That means if it is 0, this becomes 1. If it is 1, it becomes 0. It's called a NOT gate.
So basically it switches everything around.
Yeah. So the inputs to this this AND gate are A and not B. And the inputs to this are not A and B. When you combine both, you get A not B plus not AB, which is the same as the XOR. You will get the same output. So you could construct a non-linear device from a linear device, from linear devices. So this kind of power is there in electronics. All your electronics have this. And the same kind of power is in our brains, right? We talked about this. So there is, this is a neuron, right? So we are born with around 200 billion neurons. And yeah, and a neuron may connect to as many as 100,000 other neurons. One neuron can connect. See, all these are called as, what are these called? Synapses or dendrites. So these are dendrites, right? It's written here. These are dendrites. The contact points are called synapses. The contact where they attach to another neuron, they are called synapses. But these themselves are called dendrites. So these dendrites connect this neuron to 100,000, as many as 100,000 other neurons. The more the connections, the more the intelligent the person is. And all the neurons work together to give a non-linear perception. So this kind of XOR behavior is very common, right? So for instance, suppose A is cold, this input is cold, this input is also cold. So A is cold and B is cold. Then you might feel cold as well, right? And if both are hot, also you'll feel, you'll feel hot. But in all other cases, it depends on what is hot and what is cold, right? So, so that functionality is enabled by using neurons, like this, neural networks. Right? A single neuron cannot do much. It has to connect to multiple other neurons to do anything useful. So same thing with machine learning. Even in machine learning, we have a bunch of neurons connected to each other. Right? So you can actually play around. There is a website called Google's Teachable Machine Learning. So you can dump a number of, you can give it a lot of data and it will recognize whether, say, if you dump this kind of data, it will recognize different poses it will recognize the pose. If you dump a number of video samples like this, it can recognize you. And if you dump a number of music instruments, it can recognize the music. So you can do that actually. So you could choose an image project, audio project, or a pose project. If you choose image project, so standard image model and embedded image model. So you can choose standard image model. So you can dump a number of images here. You can upload or you can do this. Then based on the images, it gets trained, the model gets trained. And then once the model is ready, you can preview it and it starts to recognize similar kind of objects. So you can try this. So this is Google's Teachable machine learning, right? So did we talk about Perceptron before?
I don't think so.
Yeah, so Perceptron is like all this machine learning, this art. So if it is, if you are talking about the brain, it is natural neural networks, right? The neurons are naturally made by God. But if we talk about the man-made neurons, then we are talking about artificial neural networks, ANN. They are abbreviated as ANN, artificial neural networks. So each artificial neural network is a black box. You can think of it as a box, like this cell phone. The cell phone is a black box to me, right? What it does inside, I don't know. That's what is meant by black box. So you give some inputs, it gives some output. So for instance, to turn my cell phone on, what do I do? What do I give as input? My face, right? I put my face in front of the phone and it recognizes my face and then outputs that, yes, this is the person who is the rightful owner of the phone. And if I put the phone, if I input somebody else's face, it won't open. So input is the face and output is whether the person is the real owner or not. So it's a black box. How it's done, we don't know, right? But we know the inputs and we know the output. So here's an example. There are 3 inputs that this black box can take and 1 output. So if the inputs are 1, 0, 0, the output is -1 and so on and so forth. So output Y is 1 if at least 2 of the 3 inputs are equal to 1. So that is the definition of the functionality of this black box. What does this black box do? It will output a 1 if at least 2 of the 3 inputs are equal to 1. So this is a very simple, it is the simplest neural network and it's called Perceptron. So how can you do this? How can you make sure that this black box outputs a 1 when 2 of the 3, at least 2 of the 3 inputs are equal to 1? How can you do that? So remember support vector machines, and we talked about a line which separates men and women.
Yeah.
So can we similarly separate -1s and 1s? In this output, can we separate -1s and 1s?
By the inputs?
Yeah. Can we separate by a line?
If we can make it 3-dimensional.
Yeah,
graph,
if we can, yes, if we can make it a 3-dimensional graph, then maybe we can separate. Let us look at it. Yes, we can separate it. So these are all these are the 3 dimensions, and there is a line. A line in 3 dimensions is called. If it is 2 dimensions, it's a line. If it is 3 dimensions, it is called
3D shape.
No, what is similar to a line in 3 dimensions?
A cube.
Cylinder is not like a line, right?
A cube or
So
prism, rectangular prism.
so think of your day-to-day life, right? What is like a line in 3 dimensions? What is straight and what is like a line? Can you give some examples? A ruler,
A
yes.
skinny piece of paper.
A
or
piece of paper. A stick is round and cylindrical, right? But we're looking at something that is straight, like a paper, right? So
paper is the flattest thing I
yeah,
can think
yeah,
of.
paper is the flattest thing that you can think of, right? So the shape of a paper is actually a plane. It's called a plane. So so the straight line in 2 dimensions is equivalent to a plane in 3 dimensions, or the other way around. A plane in 3 dimensions is equivalent to a straight line in 2 dimensions. So as you can see, all these data, these x1, x2, x3, and y have been plotted. Not y, but x1, x2, x3, and you can see that the points can be separated clearly by this plane, right? So y is basically linear. It's a linear combination of input variables, and the decision boundary is linear. So you can think of y as this 0.3x. So you multiply each of the input variables by 0.3 and you sum it up. And if it is positive, then you output a 1. If it is negative, you output a -1. Right? So if you do that, you will notice that all this table is satisfied. So for instance, take the first example, x1 is 1. So 0.3 times 1 is
0.3.
Yeah, 0.3. So second input is what? In the first row?
0.
0. 0 times 0.3 is 0. And the third input?
It'll be 0 again.
0 again.
0
right?
times 0.3 is 0.
So, so the sum of these first 3 terms is?
1.
No. 0, 0, and the first term was?
1.
It was 1 or?
Oh, sorry,
0.3.
0.3.
Yeah, 0.3. 0.3 plus 0 plus 0 is?
0.3.
0.3. And there is a bias. This term is called bias, if you remember. So this, we always add some number to this. So these are like 3 features. X1 is a feature, X2 is a feature, X3 is a feature. And these are like the weights. Each feature must be weighed in machine learning, right? So the weight for the first feature, second feature, third feature is equal in this case, 0.3, 0.3, 0.3. And there is a bias term, which is 0.4. Like every human being has a bias, right? Like we are biased towards something. Like many people are biased towards one age group. They think that if somebody is above 60 years, they may not do certain things that others are able to do. Similarly, there's a bias. So this term 0.4 minus 0.4 is like a bias. So this is like the weighted sum of the features, and there is a bias. You add all that up. What is the result? 0.3. The sum of the first 3 terms is 0.3, right? Minus 0.4 is?
Negative
0.3 minus 0.4 is how much?
negative 0.1.
Yeah, negative 0.1. So the sign of that number is minus.
So it'll be
The output
negative
will
1.
be -1. So it is -1. Similarly, you take the second input, third input, and fourth input. you will notice that all these inputs satisfy this equation, right? Now, the question that you might have in your mind is, how did you decide on this equation? How did you come up with that equation? So that is what is accomplished by a neural network. So the neural network will compute these weights and this bias automatically for you. You don't have to be creative. You don't have to think a lot. Oh, what equation should I come up with? The neural network automatically comes up with this equation. In this case, it's a linear equation, right? Why linear? Because there are no powers, single dimension, single power. So that's why it's called a linear equation. And this whole thing, this whole black box, when the equation is linear, is called a perceptron. So this is basically the function of a perceptron. This is one example of a perceptron, right? So X1, X2, X3 are input neurons. Like for our brain, what are X1, some of the X1, X2, X3s?
Like, well, almost anything. Like if you're learning to identify cats and dogs.
No, for the brain, what are the inputs? The senses, right? Like hot, cold, all those are senses. So X1, X2, X3 could be senses felt by the sensory organs. And the neurons will process those features or the sensors, the senses, and then tell you whether it is hot or cold. If you are looking at whether it is hot or cold, you touch something, you want to know whether it's hot or cold. So the inputs go to the brain, and then the brain does all this neural network computation and then tells you whether it's hot or cold. The same thing is done in artificial neural networks, right? So the most important thing about artificial neural networks, see, it is very similar to the concepts that we learn in Vedas, right? In our ancient scriptures and Vedas and our learning, things are universal, things are diverse, things are astronomical and things like that, right? Same thing in machine learning and all the sciences mostly, right? So this artificial neural network functions like a universal function approximator. So it can approximate any function. That means you give any kind of inputs and you want any kind of outputs from this box. Artificial neural networks can approximately implement that function. So anything that you can think of, it is possible using neural networks. Some neural networks are the other. Now you can think, I want to create fictitious people's images. We talked in the very first class, remember? Generative adversarial network. So you just think, this is what I want. You will be able to find a neural network configuration which will do that. So that is the power of neural networks. You think, it happens. You just have to define the inputs, you have to define the outputs, and it can do it for you. That is the power of artificial neural networks. So they act like universal function approximators. So you can think of these three as input neurons and this as the output neuron. So they are like 4 neurons which are connected, and each connection has a weight. And the output neuron, the function of the output neuron, it also takes a bias term. There's a bias because your neurons are biased. After some age, you become biased. You develop your own assumptions. So this term here illustrates or represents the bias to the neuron. And the function of the neuron is like summing. It sums up the inputs, all the inputs, and produces the output. and that is mathematically represented like this. So this is called a perceptron. This is the simplest form of a neural network. Okay, we'll talk more about this in the next class or whenever we get a chance. Okay, so any questions? Okay, then let us end the class with our prayer. Asatoma Sadgamaya Tamasoma Jyotirgamaya Mrityorma Amritangamaya Om Shanti 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 Sarve Jana Sukhino Bhavantu Samasta Sanmangalani Santu. See you next week.